So what the heck is artificial intelligence anyway? There's a lot of confusion about that in the world at large, and I think vendors have kind of added to the confusion by saying that whatever they do is, of course, AI, since it's a hot term. There is no widely accepted definition, but I think the most common ones involve defining AI as a collection of technologies, not just one, that can do tasks that were previously only possible by human brains. So things like reasoning and perception and decision making and other tasks requiring kind of knowledge and judgment and so on. However, that definition isn't perfect because some of the things we do with AI, particularly massive machine learning models that digest, unbelievable amounts of data, could have never been performed by human brains. And of course, there is some debate about whether some technologies are smart enough or new enough to be included in AI. Robotic process automation, some people say, well, it's not really smart enough to be true AI. Statistical machine learning has been around for a long time, 30 or 40 years, pretty well established in business already. So how can it be AI if it's that old? I just think within a particular organization, you should have a list of what's included and what isn't. Be consistent about it. I tend to be pretty inclusive about the whole thing because all of these technologies are getting smarter. Some have been around for a while. Some are relatively newer. I don't think it really matters all that much to address those particular factors. So what are the technologies that we tend to include? So machine learning, as I say, a statistics-based technology that's kind of at the core of AI. It's been around for a while. Neural networks are a form of machine learning that are typically used for classification-oriented problems. They've been around for a while as well, 20 years or so. We have a newer form of neural networks called deep learning that is really just a more complex and multi-layered form of neural network, and that's relatively newer. It's only been widely used over the last decade or so, and people are very excited about it as the kind of newest and potentially most powerful form of AI. Natural language processing technologies have been around for a long time, both the understanding side and then the generation side, producing kind of automated text and stories and so on. Rule engines were sort of considered the last generation of AI. They are based on sets of rules, logic-based rules, if-then statements in many cases. They were at the core of expert systems that companies and the media were very excited about in the late 80s and early 90s. It turns out companies are still using them, so they're certainly not dead. As I said, robotic process automation, not the smartest of these technologies, probably the dumbest in many ways, but getting smarter all the time. And like a lot of these other technologies, it is increasingly being combined with other AI capabilities and some sort of cognitive cloud. People refer to cognitive technologies as just a synonym for AI. And increasingly, we're seeing combinations of these things in various ways. So just how smart are these smart machines? I mean, this chart, which I developed a few years ago, suggests that we've been at this for a while, and you have different task types along the side margins. We analyze numbers, we digest words and images, we need to perform digital tasks with AI, and we need to perform physical tasks. So we started with a whole generation of technologies that really support humans in performing these tasks. So in terms of analyzing numbers, we've been at that for a long time with business intelligence and data visualization and analytics of various types. The same in words and images. We had character and speech recognition that was really not autonomous at all. It was oriented to helping humans make sense of things. In the digital task space, we had business process management tools, and in the physical task area, we had sort of robots that were operated remotely. So then we get into another generation of repetitive task automation. In analytics, this might be operational analytics or scoring models, which actually started to use machine learning. In words and images, we have larger scale image recognition and machine vision, often used in manufacturing processes, even though it wasn't terribly accurate. Rule engines helped us with repetitive digital tasks. Robotic process automation is really in that space as well, which uses rules and some other technologies. And then in robotics, the modern industrial robot can perform repetitive tasks, not particularly good at responding to its environment. So then we get into another generation of technologies involving context awareness and learning, and that's typically knowing about context means you just consider multiple factors. My smartphone might tell me, Tom, you need to get to the airport now because I know your schedule, I have your calendar, and I know where you are, and I know how long it takes to the airport, and I know what your flight is, so you need to get from where you are now to the airport. That's, in a way, knowledge of context. So automated machine learning starts to move into that space. Neural networks are more along those lines. In digesting words and images, we have Q&A-oriented systems like Watson, and then in general, natural language processing, intelligent agents. We don't really have context awareness yet in the repetitive digital task space yet, but we're going to, and as I said, with combinations of other forms of AI and robotic process automation, we'll have that. And then as we get fully autonomous robots and fully autonomous vehicles and so on, that's really performing physical tasks using context awareness and learning. You notice in the next category, self-aware intelligence, we're not there yet at all. We have movies that have smart machines and robots that are self-aware and intelligent, but not in real life yet. And then as we get further along, we see all these technologies start together. I call it the great convergence. So in the end, I think these individual categories sort of break down, and the machines can basically do it all. This might be useful if you're trying to figure out, well, what's really at the core of AI? There are really only three things. Statistics, which are at the core of machine learning. Semantics, which have been at the core of some forms of natural language processing, although recently statistically based natural language processing has come to be a bit more powerful and more successful. You still have some devotees of semantics-based NLP, and then logic in the form of rules, as I said. All of those go into a series of AI methods, including things like neural networks and deep learning, machine learning. All of those are mostly statistics-based. Rule engines, as I say, mostly logic-based, and natural language processing can be either statistics or semantics-based or both. IBM Watson is an example of a technology that uses both statistics, typically in the form of logistic regression, and semantics as well to make sense of language and questions and so on. And then you have a whole variety of applications of AI. How do we recognize images? How do we recognize speech? How do we create intelligent agents and chatbots, or intelligent robots or cobots, collaborative robots? We need to do things like prediction and classification, which is the typical task of machine learning, and robotic process automation, as I said, a combination of rules and technologies that allow interfaces to multiple systems. So it may be helpful to kind of classify, is that an underlying tool, a specific AI method, or an application of AI? In terms of the technologies that people are actually using, this is from a survey that I did with Deloitte in 2017. Robotic process automation, because it's the easiest AI technology, tends to be the most common, followed very closely behind by statistical machine learning, as I say, technology that's been around for a while. NLP, more than half were using it. Expert systems, given up for dead, but still alive in half of the organizations, or 49%. Deep learning, newer and kind of coming on strong, 34%, and physical robots in about a third, mostly manufacturing-oriented organizations. So you start to see there really are a collection of technologies here. And today they're pretty much separate, although I think in many cases they'll be combined in the future.